Alright, welcome back. In this video, we're going to go over the functional groups, part 3. In this video, we're going to go over the ketone functional group, the aldehyde functional group, the carboxylic acid functional group, and the acyl halide functional group. So all of these are variations of the ketone. So I organized these functional groups in this video to make it easy as possible to remember. So they all basically are variations of the ketone, which we're going to go over right now. The ketone is an oxygen that's double bonded to a carbon. So there's a carbon right here. And that carbon is bonded to two R groups. And those R groups can be anything. Here's an example, is acetone. Acetone is arguably the easiest ketone. Very common in organic chemistry labs you probably work with when you do experiments. But more interesting is I like to put these real world examples in here. Is ketoacidosis. What is ketoacidosis? Well, first, ketones are actually able to be measured in the body. So if you go to a blood test, the physician can actually measure the amount of ketones in your blood. Why are there ketones in your blood? Okay, so when you have low glucose in your body, so your body is running on a field basically, your body will produce ketones as a source of energy. This is exactly where the keto diet comes into play. The keto diet is low carbs. When you have low carbs, you're getting low amount of calories in your body. Low amount of calories equals low glucose. So your body produces ketones, hence the keto diet, to give your body energy. Now, ketoacidosis is the uncontrollable ketone production in the body. So sometimes with diabetes actually, people get ketoacidosis, like diabetic ketoacidosis. The reason is because your body's producing so many uncontrollable ketones. You might think, why is this bad, right? Ketones is giving you energy. Well, ketones actually throw off the pH of your blood. This is really, really bad and actually will land you straight in the hospital. Your body's very sensitive to pH changes. Even the smallest pH change can actually kill you. This is why it's really deadly. Let's do aldehyde now. The aldehyde functional group is the exact same thing, except we're placing one of the R's within hydrogen. So now it's one hydrogen, one R group, and a double bonded oxygen, and the carbon in the middle. Butanol is an example. Butanol has 4 carbons, and then we have our double bonded oxygen and the hydrogen. More interestingly is cinnamon aldehyde. Cinnamon aldehyde, just like as the name suggests, is basically cinnamon. This is found on the bark of a cinnamon tree. This gives cinnamon its color and flavor. Also interestingly is perfume. So here we have this perfume in particular has cinnamon aldehyde, Chanel No. 5 Paris. This perfume has cinnamon aldehyde in it. It's very common for its color. The cinnamon aldehyde gives it its brownish yellow color. Now we go to the carboxylic acid. So it's the same thing, except that R group, or the hydrogen if you're talking about aldehyde, is now replaced with an OH group. Here's an example. This is formic acid, the least complicated carboxylic acid. It's just a hydrogen instead of the R group here. The R group is the hydrogen. I have a picture of an ant here. So ants actually have venom in them. And that venom is actually formic acid. Here's a really interesting one. This is stearic acid. Look at that huge chain of carbons. We have, how many carbons we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 carbons. And we have our carboxylic acid right here. What's so special about stearic acid? Well, stearic acid is found in chocolate. Very common in chocolate like cocoa butter. So whenever you consume your Hershey's chocolate bar or Twix or Snickers or whatever you like, you're actually eating stearic acid. Aren't these kind of interesting how you learn about these real life concepts? I'm hoping this will help you, remember these, because honestly, these real life concepts, you learn about organic chemistry, but you really want to know how to apply it to real life. Otherwise, it's just boring. But you can see how we go from like ant venom to cake, chocolate, to perfume, to cinnamon. Organic chemistry is endless. Now for the most boring one. This is an acyl halide. All we did is replace the R group with X. X is any halogen, so iodine, bromine, chloride, any of those. Here's a common one, acyl chloride. The R group is just, we replaced it, the X is basically a chloride now. So it's any halogen. So chloride or bromide, or bromine. So this is acyl bromide, because it's a bromine atom. So just replace the X with any of the halogens. Now, this is a very common thing to use in synthesis, and that's really it. There's no fun facts about these, unfortunately. I know, I'm kind of bummed out too, but there are no fun facts. It's just basically very used in common organic chemistry synthesis and in your reactions. That's it. So yeah, if you found this video helpful, please like and subscribe. And until next time, later.